Welcome to The Explainer. Picture this. Right now in Nigeria, thousands of brilliant engineering students are graduating. They've got top honors, they've survived years of rigorous study, all those late nights, and they step out into the job market completely expecting their hard work to immediately pay off. But then, they hit a brick wall. They find out that employers actually feel they simply aren't ready for the job. No way, right? Today, we're diving into this massive, absolutely critical mismatch between Nigerian university engineering training and actual industry needs. We're basing our deep dive on some really eye-opening recent research by MasterSense by Faraday. It completely strips away the academic assumptions and takes a hard, objective look at what employers are literally begging for when they hire graduate engineers. If you want to understand the true currency of the modern job market, you are in the exact right place.
Okay, let's dive right into this. To make sense of it all, we're going to cover 1. The engineering competency gap itself, 2. Redefining graduate employability, 3. The 4 skill domains, 4. Sector-specific employer demands, and finally 5. How we actually bridge this gap.
Section 1. The engineering competency gap, a critical national mismatch. For decades, the ultimate metric of success was just a stack of academic degrees. You get the grades, you secure the degree, and boom, you get the job. But today, there is a profound disconnect. And this brilliantly illustrates the issue. Employers are looking at a straight-A student and asking, okay, but can you actually problem solve on a chaotic construction site? Can you manage a project when resources run thin? They demand practical workplace readiness. The research clearly shows that disciplinary knowledge alone just isn't cutting it anymore. Actually, employers are increasingly prioritizing things like adaptability, digital competence, and interpersonal effectiveness right alongside that degree. So we're seeing this fundamental mismatch between the theoretical piece of paper a graduate holds and the immediate practical readiness the fast-paced modern workplace actually demands. So, what does this all mean? Why does this competency gap matter so much, specifically in Nigeria? Well, it's not just about a single graduate struggling to land a gig. The stakes are incredibly high for the entire country. The engineering profession is directly tied to massive infrastructure development and booming industrial productivity. And crucially, we are talking about public safety here. A poorly designed bridge, a compromised telecom network, or a faulty power grid, these have real-world, sometimes devastating consequences. Beyond that, the readiness of these graduates dictates the pace of technological innovation and ultimately Nigeria's national competitiveness on the global stage. Solving this gap isn't just some HR priority, it is literally about the safety, growth, and advancement of the nation.
Section 2. Redefining graduate employability beyond the degree. We really need to completely shift our mental model here. Employability is no longer just what you know. It's a dynamic combination. Think of it as a broader mix of your knowledge, your skills, your behaviors, and your professional dispositions that enable you to obtain work, perform effectively, and, most importantly, continue to develop. It's not static academic knowledge that you memorize for a single exam and forget the next day. It is the difference between, say, knowing the theoretical equations of concrete mixing and actually managing a diverse team to pour that concrete safely before a massive storm hits. It's all about your adaptability and how you perform and evolve within constantly changing environments. And look, this expanded definition isn't just some corporate trend or a wish list from a few picky recruiters. It is a direct mandate from Nigeria's top regulatory and professional institutions. The Council for the Regulation of Engineering in Nigeria, or COREN, and the Nigerian Society of Engineers strictly emphasize competence, professional development, ethics, and practical exposure. These organizations are the gatekeepers of the profession, right? And they are drawing a firm line in the sand regarding what makes a true professional. This shift in expectations is institutional, it's permanent, and it's absolutely critical for a graduate's survival in the field. Let's move to Section 3, the 4 skill domains, the ultimate employer wish list. Now, what's really interesting here is how employers chunk these necessary skills into 4 specific domains. First up, the technical domain.
This means practical engineering knowledge heavily mixed with rigorous safety awareness. It's not just about the math, it's about keeping everyone on site alive. Second, digital. Navigating modern industry software, from CAD programs to complex project management tools, is absolutely non-negotiable today. You've got to have it. Third, interpersonal. You might be a literal genius in the lab, but can you communicate complex ideas clearly with your team on a noisy site? Can you manage conflict? And finally, professional. This covers your ability to problem solve on the fly, your adaptability when things go completely wrong, because they will, and your actual project organization. If you are missing just one of these pillars, your overall employability drops significantly.
Section 4. Sector-specific employer demands, where the skills apply.
There are three massive industries that largely shape this landscape in Nigeria: construction, telecommunications, and power. Think about it. If you're in the construction sector, a lack of safety awareness isn't just a bad grade on a transcript. It is a literal structural hazard. In telecom, the landscape shifts incredibly fast. If you can't adapt to new digital protocols instantly, your skill set is obsolete within months. And in the power sector, practical engineering knowledge and real-time problem solving are tested daily under intense pressure just to keep the grid running. These are not generic office jobs. These specific sectors provide the harsh, real-world testing ground for young engineers, dictating the unforgiving demands of the labor market.
Which brings us to our final section, Section 5, How to Bridge the Gap, the Roadmap Forward.
So the crucial point is, how do we actually fix this? It requires a coordinated three-step roadmap. Step 1, implement stronger industry-linked training. Universities simply cannot operate in academic silos anymore. Their training must be directly tied to what the industry is doing right now through robust internships and real-world project partnerships. Step 2, focus on more intentional skills development. We need to deliberately embed those digital, interpersonal, and professional skills into the daily curriculum, rather than just hoping students kind of pick them up by accident. And step 3, ensure greater alignment between engineering education and workplace realities. The curriculum itself must physically mirror the actual demands of the major sectors we just discussed. It's going to require a unified, serious effort from academia, industry leaders, and the students themselves.
Which leads us to a really critical question. Will Nigeria's engineering education evolve fast enough to build the nation's future? The gap is clearly defined, and the roadmap is right there in front of us. But how we actually execute this transition will directly determine the infrastructure, the safety, and the global competitiveness of tomorrow. Thank you so much for joining me on this explainer. I'll leave you to ponder how we might all contribute to bridging that gap.
Please like, share, and subscribe to Master Sense by Faraday, and turn on notifications so you don't miss new and upcoming videos. Drop a comment below and tell us what you'd like to see next.
Welcome to this explainer. Today, we're tackling a massive, incredibly relevant topic that affects thousands of brilliant minds every single year. We're going to break down exactly what employers are looking for, what's missing, and how you can position yourself to not just get hired, but to absolutely excel. You spend years studying, passing grueling exams, and celebrating that graduation day, only to face a job market that seems to speak an entirely different language. So let's explore the intense friction between earning an engineering degree and actually being employable in the field, specifically looking at the landscape right now in Nigeria.
So why do engineering degrees rarely guarantee engineering jobs? It's a tough question, but you see it all the time, right? The valedictorian who struggles to land an entry-level position, or the dedicated student sending out hundreds of resumes with zero callbacks. Honestly, it feels like a broken promise. The expectation is simple. I get the degree, I get the job. But the reality is far more complex, and frankly, a bit of a harsh wake-up call. The modern engineering landscape doesn't just want a piece of paper, it wants proof of capability. And that gap between the degree and the practical capability is exactly what we need to unpack today.
Now, to be clear, employers absolutely expect you to have a rock-solid grasp of the theoretical fundamentals. Make no mistake, the theory matters immensely. Whether you're in civil, electrical, mechanical, chemical, petroleum, mechatronics, or computer engineering, you must understand the core principles of your chosen field. The physics, the math, the fluid dynamics, the thermodynamics, that is your foundation. Nobody's going to hire an engineer who doesn't understand the underlying science of what they're supposed to be building or maintaining. You have to earn that foundation. But here is where the story completely shifts. Passing exams simply isn't enough anymore. Hiring managers aren't bringing you on board to take a multiple-choice test. They're hiring you to solve expensive, real-world problems. Can you take that fluid dynamics equation and use it to figure out why a pump in the plant is cavitating? Can you step onto a muddy construction site or into a loud, vibrating manufacturing plant? Or sit in a high-pressure design office and actually translate what you know into a workable solution? That is the real test. That's the moment of truth for literally any graduate engineer. Think about it this way. Classroom learning is incredibly structured. It's predictable. All the variables in your equations are neatly provided, and the answers are in the back of the book. But workplace performance? It is pure chaos. Variables are missing. Budgets are tight. Equipment breaks down at the absolutely worst possible times. The gap between these two worlds is vast. It's the difference between knowing exactly how a generator works on paper and being able to diagnose a blown relay during a massive facility-wide blackout. And hiring managers across Nigeria are echoing the exact same frustration. They'll tell you straight up that many graduates possess theoretical knowledge but completely lack practical exposure. They see candidates who look absolutely fantastic on paper but freeze up the second they step onto a job site. And you can't blame them. They recognize the hard work it took to get the theory, but they're terrified of putting multi-million-dollar equipment or critical infrastructure projects into the hands of someone who has never actually applied that knowledge in the real world. So let's get specific about what's missing. If you're just memorizing formulas but have never touched a wrench or monitored a live process, employers are going to pass on your resume. We're talking about troubleshooting, which requires an intuition you only build through experience. Equipment handling means understanding the physical quirks of a machine, not just its schematic. Process monitoring is about seeing the data in real time and knowing instantly when things are drifting out of spec. Design interpretation, that's taking a 2D blueprint and visualizing the 3D reality. Maintenance support, project execution, these are the missing links. When employers complain about a lack of practical exposure, these are the exact skills they are desperately looking for. So, how do we bridge this divide? It's time to lay out a concrete action plan for employability. These right here are your golden tickets. Nigerian employers place immense value on these specific, hands-on exposures. Take your SIWS, the Students' Industrial Work Experience Scheme. It isn't just a requirement to check off. It is a full-blown audition. Internships and industrial training are where you finally get your hands dirty. And listen, instead of choosing a safe, theoretical paper topic for your final year project, choose a project that forces you to actually build something, test something, or solve a localized industry problem. Familiarity with real engineering systems is exactly what transforms you from a student into a professional in the eyes of a hiring manager. Think of it as a ladder of competence. A graduate engineer who systematically acquires real-world experience has an undeniable advantage over their peers. Step 1. Get comfortable handling industry-standard tools like AutoCAD drawings. Step 2. Jump at the chance to participate in plant shutdowns so you can actually see the internal anatomy of these massive industrial systems. Step 3. Get into the lab to assist with routine maintenance and testing. And Step 4. Actively contribute to field operations. If you can sit in an interview and confidently point to these specific steps, you aren't just telling them you're an engineer, you are proving it. Because this gap is so widely recognized, we're actually seeing massive structural changes in the industry right now. The demand for job-ready competence has sparked a renewed emphasis on formalizing the transition from theory to practice through something called an engineering residency. Just like medical students do a residency to learn how to actually treat patients, Engineering residency programs in Nigeria are being designed to provide structured, supervised, hands-on development. It's a brilliant acknowledgement by the industry that, competence isn't magically born on graduation day. It is forged through guided experience.
I want to leave you with this provocative thought. Take a hard look at your resume and your skill set. Are you just classroom trained, equipped only with the theory? Or are you truly job ready? If you find yourself leaning toward the former, hey, don't panic. Just use the blueprint we discussed today. Go aggressively after those internships, embrace the field operations, and seek out that structured practical development. Push yourself toward the hands-on experience that actually gets you hired and sets you up for an incredible engineering career. Thanks for joining me on this explainer. I'll catch you on the next one.
Like, share, and subscribe to Master Sense by Faraday, and turn on notifications so you don't miss new and upcoming videos. Drop a comment below and tell us what you'd like to see next.
Welcome to today's explainer. We're jumping right in today because we've got a massive illusion to shatter. So what does it actually take to be a highly sought-after engineering graduate in Nigeria right now? Honestly, the stakes are incredibly high. We're not just talking about your individual career here, we're talking about the industrial resilience of an entire nation. If you're kind of coasting on the assumption that just getting a degree, memorizing a textbook, and spitting back theory is the finish line, well, it's time to recalibrate. Today, we're diving deep into the source material to uncover exactly what elite employers are desperately searching for and constantly struggling to find. We're going to break down the critical thinking mindsets that can literally transform a standard graduate into an indispensable candidate, the kind a company just can't afford to pass up. Let's get right into it. There's this massive, often completely unspoken gap between the academic classroom and the actual company floor. For 4 or 5 years, it's so easy to exist comfortably inside what I call the academic illusion. You're handed clear instructions, you memorize these perfectly balanced formulas, plug in the numbers, and boom, you get a neat, tidy answer that matches the back of the syllabus. But the second you graduate, that whole paradigm completely shatters. Engineering employers in Nigeria need professionals who can think way beyond memorization. The real-world demand is relentlessly focused on dynamic problem solving. Imagine stepping onto a plant floor on day one. There's no textbook answer key, right? Variables are unknown, budgets are suddenly slashed, materials are delayed. Employers aren't hiring human calculators. They are paying for a mind capable of navigating extreme ambiguity and actually forging a path forward. And this real-world problem solving is not just a simple checklist you memorize. It's really the diagnostic heartbeat of the entire engineering profession. It's a methodical, deeply analytical approach that happens in real time. First up, you have to identify issues, and I mean proactively. You've got to spot a silent, creeping issue before it cascades into a total system failure. Then, you analyze the causes. You don't just put a Band-Aid on a symptom, you drill down to find the underlying why. Step 3 is where elite critical thinking really shines, evaluating alternatives. You're weighing pros, cons, risks, and rewards of totally different approaches, all at the same time. And finally, implementing practical solutions. Actually, let me emphasize practical. Your brilliant theoretical fix means absolutely nothing if it doesn't work within the strict confines of real-world budgets, local materials, and crazy tight timeframes. This continuous loop, that's exactly how value is generated on the job.
Now, that diagnostic loop is absolutely vital, because let's face it, the real engineering world is inherently chaotic. Just picture this. You're standing on a major site in Lagos. A critical heavy-duty pump suddenly fails at the exact moment the local power grid collapses. And honestly, that is a daily reality in Nigeria. Instantly, you're looking at a massive drop in production efficiency. You're watching cost overruns tick up by the minute. Severe construction delays are ripping through your project timeline, and you've got very real safety risks threatening the crew. This isn't a theoretical exam where you have 3 hours in a perfectly quiet hall. No way. This is rapid-fire, high-stress reality, and process loss is happening right in front of you. If you're in the middle of this escalating crisis, pulling up a memorized thermodynamics formula from your second year of uni, yeah, that's not going to save the day.
So, when faced with that overwhelming wall of operational chaos, what do employers actually want? They demand one highly specific trait: an intelligent, logical approach. When the grid drops, the supply chain breaks, and the pressure is coming from literally every side, the absolute worst thing you can do is panic, freeze up, or start frantically guessing. Organizations are desperately looking for an anchor in the storm. They need composed professionals who have the discipline to just take a deep breath, step back from all the noise, and systematically apply that diagnostic process we just talked about. They want someone who can isolate the variables intelligently. This unwavering, logical composure under pressure, it's not just a nice, soft skill. It is the definitive marker that completely separates an average graduate from an exceptional, highly sought-after industry leader.
And this isn't just my opinion. Industry reports on Nigerian graduate employability are crystal clear on this. They consistently highlight critical thinking and solution development as the absolute top requirements. We're talking about a universal mandate here. Whether you're in civil, mechanical, electrical, or software engineering, the core demand is exactly the same. The hard data proves that the modern workplace values your ability to think critically and develop actionable solutions way, way more than your ability to just recall academic theory. It's the defining metric of true employability. HR departments and lead engineers, they aren't just scanning resumes for a 4.0 GPA anymore. They're probing candidates to see if their minds are actually calibrated for complex problem solving. This right here is the ultimate gatekeeper to your career.
Okay, so how do you actually manifest these analytical traits in your daily work? Well, first, it starts with asking the right questions. Instead of looking at a broken machine and asking, how do we patch this right now? An analytical engineer asks, what specific operational variable caused this pressure valve to fail in the first place? Second, you've got to use data to support your decisions. You simply cannot operate on gut feelings. You gather the metrics, you analyze the logs, and you let the hard data drive your solution. Third, and this is a big one, you have to master second-order thinking, basically thinking through the hidden consequences before you act. You have to understand how a quick fix to System A might accidentally overload System B. And finally, you have to execute all of this under intense pressure, making sound, rational judgments even when the clock is ticking and the financial stakes are sky high. Now, the secret to landing that dream role is proving you have these skills before you ever step foot into an interview room, and you have specific arenas to build this exact narrative. Take your industrial attachment. It's not about fetching coffee or just shadowing someone. It's prime real estate to intercept actual workflows and prove you can handle real-world variables. Treat your academic projects and lab work like genuine corporate contracts, not just grades to be earned. Push yourself by entering competitive engineering challenges. And perhaps the most powerful arena of all, community engineering initiatives. What an incredible way to demonstrate your value. If you can identify a real issue in your local environment, say a failing drainage system, analyze the root cause and build a practical functioning solution with zero budget, wow, you're proving you're an innovator. Those are the exact stories of analytical excellence you need to be telling.
So, if you want to become an irresistible asset to any engineering firm, you've got to embody this specific professional trifecta. First up, show relentless initiative. Don't wait for a manager to assign you a task or explicitly tell you how to fix something. When you see an inefficiency, step up, claim it, and own the process. Second, deeply demonstrate your analytical reasoning. Prove to your team that you can take a massive, intimidating problem and break it down into small, manageable parts using pure logic and hard data. And third, remain completely solution-focused. In any challenging environment, it's incredibly easy to just complain about an unstable power grid or a lack of resources, but the engineers who get promoted, the ones who end up leading teams, they are the ones who focus 100% of their energy entirely on the fix.
Which brings us to a really critical moment of self-reflection. When the pressure is truly on, when critical equipment fails, the project budget is totally exhausted, and an entire team is looking directly at you for answers, what are you going to do? Are you just relying on a memorized formula, hoping the academic theory will somehow save you? Or are you actively creating a real, practical, intelligent solution? The Nigerian engineering landscape doesn't just need a higher volume of graduates right now. It desperately needs sharp, adaptable, analytical problem solvers. It needs forward-thinking innovators. Thank you so much for joining me for today's explainer. Keep developing those critical thinking skills. Never stop asking the hard questions, and I'll catch you in our next deep dive.
Please like, share, and subscribe to Master Sense by Faraday, and turn on notifications so you don't miss new and upcoming videos. Drop a comment below and tell us what you'd like to see next.